In this session, we will discuss the question related to the diffraction and interference, mainly diffraction and interference. So in the question, they mention two coherent waves, two coherent sources emit a wave of wavelength lambda, which is in phase. At a point where the two waves meet, the phase difference is 90. Which of the following could be a part difference? So the relation between a phase difference and part difference, if the part difference is one complete wavelength lambda, the phase difference is equals to 2 pi radian, or we can also say 360 degree, because 2 pi radian in terms of degree, that is 360 degrees. So if we have a phase difference of 90 degree, then what will be the part difference? It will be x. When we cross multiply, so x will be equal to 90 degree divided by lambda divided 90 into lambda divided by 360. When we simplify, it will be lambda by 4. So D will be the right answer, because the relation between the phase difference and part difference, when one complete wavelength is the part difference, the phase difference is equals to, this is a phase difference. So phase difference or angle difference is 360, the part difference is lambda. So if angle difference is 90, then the part difference will be equal to x. Then in question 3, 4 diagram shows wavelengths approaching the slit, in which diagram the diffraction greatest. So we know the diffraction is greatest when the wavelength is approximately equal to, or wavelength is, when it is equal to, then it is maximum diffraction. So when we check the options, the wavelength is the distance between the two waves, a wavefront. So this is a wavelength lambda, and this one is d. So it appears that wavelength is less than d. When we check this b for question number 3, so when we measure this lambda and this gap, so it appears that lambda wavelength is approximately equal to gap size, so we'll observe a maximum diffraction. Here the wavelength is smaller and gap is much larger. At this point also wavelength is smaller and gap is much larger. So when wavelength is approximately equal to gap size, that time we'll have a maximum diffraction. So B will be the right answer for this. Only the diffraction and interference question we will do. As well as the superposition. In this one, as you can see, noise cancelling headphone. There are headphones which are known as a noise cancellation headphone, were first invented to cancel the noise in airplane and helicopter cockpits, because there's a continuous noise from the engine of the helicopter as well as the airplane. So to cancel out that noise, they use noise cancellation headphone. They work using a principle of superposition. How it works? Like example, if these are the headphones, so these noise cancellation headphone, what they produce, these noise cancellation headphone, like example, if the sound is coming from the engine, so this is just a representation, because the sound waves are not transverse, it's longitudinal, just a representation. So if the sound is coming from the engine, to cancel out this, what these headphones will do, this produce a same frequency sound but anti-phase, opposite phase, in an opposite direction. So as a result, what happened, when the two traveling waves combine with each other and they cancel out the effect of each other, if they are anti-phase, so there will be a destructive interference, and as a result of destructive interference, the pilot won't be able to hear any noise from the engine. So they work using a principle of superposition. A sound wave passes through the headphone, and detected by the microwave, and electronic circuits send out a signal to loudspeaker so that it produces an opposite wave. Compare the property of two sound waves necessary to produce a complete cancellation of two waves that reaches the ear. So how these noise cancellation headphone works, or how they completely cancel out the effect of each other. Number one, the waves which are produced should have the same frequency, because if they have different frequency, like the frequency of this wave, say 20 hertz example, and this one is say 25 hertz or 125 hertz, so it won't be able to cancel out. So the condition to completely cancel out, they should have same frequency, they should have same amplitude as well to completely cancel out, and there should be they should be anti-phase or opposite phase. So number one, it should be same frequency, or we can say wavelength. Number two, it should be same amplitude to cancel out, and it should be in opposite phase. So when they are in opposite phase, or you can say phase difference should be 180. So when these two waves will join or combine, as a result, the two waves will completely cancel out the effect of each other, and we will observe a destructive interference. Is it clear, this question, that how the noise cancellation headphone use the principle of superposition to cancel out the noise from the engine? But these noise cancellation headphone, like example, if we are using it for a human speech, they are not effective. What is the reason why the human speech it is not effective? Because all of us are not having the same frequency. We are producing multiple frequencies. We are not producing a constant frequency. Even our amplitude vary. But because the distance between the pilot and the engine remain the same, so amplitude of the sound more or less remains same. But for us, if a person is nearby, he will produce a louder sound, or a higher amplitude will be there, and a person far away from us will have a lower amplitude. So it will be difficult to cancel out the human speech, as it is having a variable frequency and amplitude. Because in the next part, they're saying in practice, incoming sound is reduced in volume rather than completely cancelled. Noise cancelling headphones work well with the noise from the jet engine. They are not very effective in cancelling the speech or a music. Explain a reason for that. Like, why these same noise cancellation headphones we cannot use to cancel out the completely human speech or a music? So the reason is that because if the sound which is coming out from the engine is having a constant frequency, but a human speech is not having a constant frequency, a constant pitch, we can also say. So speech or sound waves or frequency will change for a human. So the noise from the engine is having a constant frequency, or you can say pitch or loudness. Whereas the human speech or music, even if you're listening to a music, you will find there are a lot of different musical instruments are there which are producing a different sound or sound of different frequencies. So it will be really hard for this noise cancellation headphone to cancel out all of the sound. It can reduce some, but it cannot completely cancel out all of the sound. So speech or a music is having a variable amplitude and frequency. That's why it is difficult, or you can say amplitude or pitch or loudness or pitch. So it is difficult to produce multiple frequencies to cancel out the speech or music. So it will work, but not effective. It can reduce it, but it is not very effective in cancelling out the speech or the music. This is about polarization. So we are only doing the question related to the interference. As you can see here, the diagram shows a path of two microwaves arriving at point S. So the two microwaves meet at point S. The wavelength of the microwave is 12 centimeter. Explain why S is a cold spot. Assume that there is no other microwave. So first, what we want to do, we want to find a part difference. Part difference means the difference between the difference in the distance between the two waves in terms of wavelength. We call that as a part difference. So when we work out the part difference, like example, the first wave travel 18 centimeter and the 6. So the first wave 18 plus 6, so that is equals to 24 centimeter. That's the total distance traveled by first wave. The second wave traveled 30, then bounce back and 12. So 30 plus 12, so it means that is covered 42. So when we work out the part difference, what will be the part difference? So it will be 42 minus 24. So 42 minus 24, that is equals to 18. So 18 centimeter is a part difference. But in terms of wavelength, because if one wavelength, as we know, the wavelength is equals to 12 centimeter. So one wavelength lambda is 12 centimeter. So if there is a 18 centimeter, then how many wavelengths are there? X. Cross multiply. So in terms of wavelength, how much is this? So 18 lambda divided by 12 lambda. So it is 18 divided by 12, basically, which is 1.5 lambda. So when you have a part difference of 1.5 lambda, if part difference is half lambda, 1.5, 2.5, 3.5, what kind of interference will occur? Constructive or destructive? If the part difference is half lambda, 1.5, so there will be a destructive interference. So if there is a destructive interference, then what will be the result of destructive interference? If these are the microwaves which combine to produce heat, so what we'll have a cold spot. Like cold spot means at this point the two waves completely cancel out the effect of each other. Is it clear that how we work out why there is a cold spot at this point? So the two microwaves, when they combine, they cancel out the effect of each other. Destructive interference occur as the part difference is 1.5 wavelengths. Uneven heating can be reduced by placing a food on a rotating turntable. Explain why this will reduce the uneven heating. Look, yesterday we discussed this concept, like if you place a food, so as a result of destructive interference, there are cold spots. Like example, these blue parts are representing the cold spots. So how we can overcome this cold spot? So we place this, you will always find in a microwave oven, there is always a turntable which is rotating when you place the food inside the microwave oven. What is the reason for that? Because like maybe right now at this position there is a cold spot, but because the food is continuously changing the position, so it will reach a point where there is a constructive interference or there is a hot spot, so it will reduce the uneven heating. Otherwise, if it was there was no turntable, and this food is kept inside a microwave, so it will have uneven heating. So how we write the answer for this? So basically when the food move on the turntable, it moves through hot and cold spots. So all parts of the food receive the same amount of energy. Or so as a result, when all the parts of the food receive the same amount of energy, we can overcome these hot and cold spots. Is it clear, part C, that how rotation of the food can make sure that there's an even heating of the food inside the microwave oven? Then wavefronts of a light, when they're passing through a edge or through a slit, this means that the light bend, and this effect is called diffraction. The diagram shows the longer wavelength, the more the light, because longer wavelength is there, diffraction is more. The draw diagram on the diagram on the left is for red light. On the diagram on the right, show the effect on the blue. So blue light, because in terms of wavelength, blue, when we work out, it is higher frequency or shorter wavelength. So it will have a small gap between the two wavefronts. So as it is having a smaller gap between the two wavefronts, so here the same gap but wavelength is shorter, so it will have a small diffraction. How we represent a small diffraction? The wavelength should not change, you should make evenly spaced, but the diffraction should be small. So this is how the blue light is diffracted. The next one, if the red light passes through two slits, they are closer, they spread out and overlap to produce a pattern of a light and dark bands or fringes. Complete a diagram to show how overlapping of a wave produce a pattern of bright and dark. So how we represent, like, because wavefronts represent the identical point, so these all are crest. So when the wave will spread, and there will be a spreading of the wave, so region where these two will combine, like the wavefronts combine with each other, what we'll observe, a constructive interference. And the dotted line, like if I draw the dotted line representing, because if these are representing the crest, so this is a crest, wavefronts represent identical points, so crest, crest and crest. So dotted line, there will be troughs. We don't have to draw this dotted line here, but after that we can draw that if there is a dotted line which is for trough, so as a result what we will see, there will be, because crest joined with a trough, so we'll observe destructive interference. Here also crest joined with trough, destructive interference, crest joined with trough, destructive interference. So some regions where the crest joined with crest, there will be a constructive interference, and some region where crest joined with a trough, there will be a destructive interference. As a result of diffraction, the two waves combine with each other. In this question, the spacing between the two bands, two dark band, is inversely proportional to distance between the slits. That we already discussed. If this is on the screen, and we have the bands. These are the bands, bright and dark. So they're saying the distance between the band, this is x, is inversely proportional to the slit, the gap size. So x is inversely proportional to d. Whenever two quantities are inversely proportional, their product is constant. So we can say x into d is equals to constant. So the two dark bands produces inversely proportional. The red light is shown. Two slits are separated by 1.2 millimeter. So that is a distance. Sorry, that is x. And sorry, the two slits are separated by 1.2. So this is d, not x. And the distance between the pattern is 0.6. So that is x. How far the pattern would be if the distance between the two is reduced to 0.4. So this is another d. So this is d1, this is x1, and this is d2, and we want what is the distance between the fringes. Whenever two quantities are inversely proportional, their product is constant. So we can say x1 into d1, like this, the spacing between the fringes and the slit, the product will be constant, and x2 into d2 will also be constant. Or we can also say x1 d1 is equals to x2 d2. So we substitute the value. We don't have to convert the unit when there's a division or comparison or ratio. You don't have to convert the unit, as it will not make difference. So d1, x1 is how much? 0.6. d1 is 1.2. x2 we don't know, and d2 is how much? 0.4. So this 0.4 is multiplied, other side it will be divided. So what will be the value for x2? 0.6 multiplied by 1.2, that is divided by 0.4, so it will come out as 1.8 millimeter. So 1.8 millimeter will be the new spacing between the two dark bands. Is it clear, this one? Any doubt till this point? So whenever a diffraction occur, the gap size and this the bandwidth, like the distance between the fringes and the distance between the slits, are inversely proportional of each other. Then describe the effect on the pattern if the distance between the two slits gradually increase. So if we increase the distance, as we know they are inversely proportional, if we increase the distance between the fringes will decrease. So what pattern we will observe? So as we are increasing the distance between the slits, so initially the bands or slits are closer, but when we increase the distance between the slit, the distance between the fringes will, or between the lines, on the screen will decrease. And because it's of 2 marks, so one, the gap, as we are increasing a distance, so at a time will come when there will be still fringes will be provided by overlapping. So initially the band will get closer together, and eventually the gap is too large, like the gap or the size is too big, so maybe no fringes will be seen. or no lines will be there when gap is too large. So this is what happened when interference pattern, the observation is there when we are increasing the distance between the slits. So these are some questions related to the topic diffraction and interference. The next session we will do Doppler effect and pulse echo technique, and we will do questions related to that as well. Any question or a doubt related to the class today?